Yeah, if you wanted to get started, I'll get started here. So welcome back, everybody, to Everyday Esoteric. I am Alex, your skeptic. With me is Martin, your mystic.
Hello.
And today we are going to skew a little bit away from the mystical and into the sort of not mundane. I don't want to refer to it necessarily as the mundane, but into something that I think everybody can into, at least in this case, something that everybody can recognize. And we'll be talking about math. And some of the other subjects that we go into, I think, will be a little bit less everyday. The plan is to go into some things like computer science and physics and other complex or difficult to wrap your head around disciplines and bring them down into the level of the layman. But before we get too much into that, Martin, how are you doing?
I am doing good. As of time of recording this, it's a Monday evening. That's usually when we're doing our recordings, by the way. Um, just starting my week off. It sucks coming out of the weekend and when you're busy all week, or not week, but when you're busy all weekend, and then you kind of have to go back to work, and it's just not as fun. I mean, that's just kind of where I'm at right now. Like
It's very
I don't want to
true.
say dreading the rest of the week, but it's a slog. And then I don't know what we're doing next weekend, but then the following weekend is my birthday,
Mm,
and then we're gonna have a little something down here for that. And then it's not
right.
too long until I come up to Pennsylvania. One for your wedding, and then visit fam. Excited to see mom and all that. So like
Yeah.
the shorter the weeks are, the better right now.
Yeah, I've noticed that there was, at least in one of my recent months, there was a stint of a lot of days off and like shorter weeks that have made these last couple real 5-day weeks a bit of a slog. The I'm definitely getting some kind of a rash in a place that I don't really want to have a rash, and it's going to make this week very miserable as I have to wear real pants to work. And yeah, which is TMI for our listeners, but that's also a thing that happens when you've got parts of your body and you're an adult, I guess.
That just it's popping up.
Well, and
I'm
the
sorry to hear that.
you remember, well, you remember the last time I got it. I think it was because I shaved in a place, and the I think it just wasn't used to it being shaved in that place, and now I guess maybe something similar is happening again this time.
Yeah, Alex's baby soft skin doesn't like specific types of irritation, I guess. Out of all the irritations and manifestations that he has going on down there, he just does not like that.
Yeah, I mean, anyway, but as far as other things that maybe we can leave in an episode, the I had my we had a little bit of a rough realization with our fence, but we've got a plan of action. I have a plan of action at least to make the most of it. I don't think it's a entirely scuffed cause. I think there's just some places where we need to sort of adapt and overcome, get the right fixings and things, and get some different hardware than we would have been normally looking for, and we'd be good to go. But making a I was mostly working on a Christmas, or not Christmas, birthday present for Sabrina at the time. This whole what do you call it? This whole weekend. A lot of It's Always Sunny in Philadelphia on in the background while I did some sewing.
Nice. I don't know. Oh, I have started watching the show Lucifer, and it's become like a guilty pleasure. Like it's not. I wouldn't call it a like. It's not an Oscar-winning TV show, but it is good. And then coming off of watching uh, the show The Sandman, the Lucifer in the Lucifer show is the same one of the Sandman universe, which is really neat. So watching all of that, and then it effectively segues right into the show Lucifer, which is really cool.
Yes, I have the first volume omnibus of Lucifer actually in comic form, and it is the comic is very good in my opinion. Uh, I don't know much about the show other than I know that like these things tend to do. They tend to act writers they want to have their own, they want to make a name for themselves, and so they're given a original thing that is great on its own, and their job is to just adapt it to the screen, but then they do too much and try to make it their own thing to get a name for themselves, and then they fuck it up royally, is what usually ends up happening, i.e., for Exhibit A, The Witcher.
Yeah. And it's bound to happen, but I think in a case like this, it's entertaining enough where, you're not even plugged into the fact that it's a comic book.
Right.
It's not really attached to the larger universe. I think if you're paying attention to what's said and the events going on, you probably could make that justification, whatever. But it's just like a fun turn your brain off and you watch Lucifer get into hijinks, being in a place, after cutting his wings off.
Yeah. But I think with that, then we'll step into our first foray to the math world. And in, I think, a suitable fashion, I want to talk a little bit about not necessarily anything concrete or any cool phenomena one way or another. I want to look at the philosophy of math, the meta of math. And so that's what we're going to be examining first, is sort of like how you think of the Qabalah is a way of thinking in terms of a mystic or religious or whatever sort of orientation on the way that the world works. Math is a thing that we use to try and make sense of the world. And there's a lot of different ways that you can think about math in terms of it as this tool and as this way of thinking and how it manifests. Part of my background as a computer science degree holder involved learning a lot of maths, as well as some of other sciences that utilize mathematics to help explain their principles, physics being a main example. Some of the major themes of these varied schools of thought center around the realisticness of mathematics, the importance of logic and rigor, and the truthiness of this construction that we have itself. We won't be touching on every single individual branching thought path, but pointing out and discussing particular things in regards to these schools of thoughts and what I suppose gives me my faith in it, which is the principle of unreasonable effectiveness. A quick definition before we start, because it's going to be a word and a thing that shows up over the course of this series, and I'll reiterate later. But an axiom, for our listeners that are not familiar with what that is a proposition that one can be regarded as established and self evidently true. An example being something like 1 plus 1 equals 2. The idea of having one thing and then another one thing and putting those two one things together creates what you know of as two is, it's just is, right? That's what that is, and that's what an axiom is. You try to choose an axiom based off of the self-evidenceness of its truth, which is the point of the definition.
You know, and I even have this in my notes here, but I've never been really good at math. But I think I have, I guess, fostered a firmer sense in the concepts behind math. Like, and I think it's probably like the economy that I've had to take and the chemistry and things like that, where I learn it from conceptual level. But even the things that I couldn't like formulas have always been very hard for me for some reason. So like that has always kind of like struck me, like almost to like a level of anxiety when I'm put into a spot where I have to like perform mathematics. So if anybody else is listening to this, like I am not like a numbers person, but I'm fascinated to learn more of the theory and the concepts behind numbers and how numbers work.
Well, and I definitely won't be trying to like explain to you how numbers work so much, because there's the school I think the schools of thought definitely try to give you a grounding on how one might decide that numbers have come to be. How did they come to be? Uh, but we'll dive into that, and I'll start here with what do I mean when I say, like, what are these schools of thought, and like, let's orient ourselves a little bit. And so most mathematicians are typically ascribing to multiple schools of thought, because they are compatible with each other, and we'll talk about the main ones that a modern mathematician ascribes to. The typical understanding, and this is also what people teach in terms of like how to look at math, which is Platonism, formalism, and conventionalism. Which, for the acute listeners here, Platonism does come from Plato, way back in the day, Greek or Roman, can't remember what his deal was. That philosopher and his approach to how math should be considered is where the root of that word comes from. Um, but I think that normal people tend not to think of math as any more than just, what it is, math. The 2 + 2 = 4 because it does. And, you look at the number line and you see that moving two places takes you from 2 to the 4. So that's how it works. And it's pretty neat. So someone who is maybe paying a little more attention would likely understand that two is just the symbol we use to represent the quantity, or rather, what has our brain has decided is to be two. And at some point, we'll talk about infinity and how if infinity isn't a number, it's a size. And tend to piss off the smooth brains out there. There is no such thing as saying some infinities are bigger than others, in a sense that people typically use it completely wrong, but we'll see about that in another episode.
So I love the fact that already math is getting super esoteric. Like a lot of the modern occultist, whatever, is there is like a through line to Platonic thought, which is really cool. And then even just the basic concept of like what a number is, like you understand what a two is, and we're like already hit with abstract symbolism. Like we're naming, or we have a pictorial representation of a concept, and I don't think any most people probably don't even consider that when they think of numbers. Like we can understand when we have a cookie and then we have an additional cookie. We can call that two cookies. Since we've started studying for this podcast, I do see quite often how things are named not necessarily for what they are, but for the qualities that they have. Here we have the concept of two, and the concept has that symbol, but the concept could be represented by two cookies, two rocks, whatever. But when I say two, I immediately conjure the symbol of the number two in my mind rather than any other nebulous meaning of two. So it's like our numbers are just the archetype, and two is just the archetype of two, where conceptually it has no shape in no uncertain ways. Um, and from, I guess, a mystical perspective, it's almost like when you talk about a god, say Zeus. People of a certain age range will understand Zeus in the Disney animation, and that imagery has a through line through texts and through pottery and art. Same thing with Thor, from the modern the Marvel movies. But they also represent an archetype of something conceptual.
Right. I mean, like, the Thor that you see in Marvel was obviously based on some kind of depiction from the Nordic background of everything, who was depicted probably by some real guy who existed at some point and just looked enough like whatever the description was at that time. And I'm not sure exactly where the step zero chicken and the egg came first there for that one, but uh, as far as like you're saying with the archetype of two, I I feel like it's the brain the brain's very spooky, and I like it, like you exactly said, it's not in there in your head as two cookies. Like, it's not in there as two rocks. It is somehow the concept of two is stored in almost uncomprehensible manner. But it's there, you know it, you know that it's not one, and you know that it's not three.
Yeah, and that's like when we talk about archetypal symbolism in the occult context, that's a like we're almost talking about the same thing. So it's funny hearing it from like describing these things just for something that we use every day, and not just like
Yeah.
some old artistic representation of some deity.
Right. And so the fact is that, like mysticism and the religious studies that we've been doing, there's way more to math and the way of thinking about it than you see on the daily or regular basis. The figuring out the difference between between how fast you're driving and what the speed limit is a very quick calculation that you have there. But like those numbers and your like the even the ephemeral way that your mind is able to organize those symbols and do those calculations is all crazy. But we're gonna talk about another quick little concept here, um, which is the idea of a priori and a posteriori, which these have their roots in similar Roman philosophy. I think it is, might have been Greek. It's that section of the world philosophy. And so, a priori is knowledge that one can derive solely from reason. It's something that you can figure out from a sentiment. So, if I say that I have eaten 4 burritos, which is amazing in and of itself, so I've derived that it's amazing, but and then I can get from that I have eaten more than 3. That is something that it can very specifically tell based on the the 4 burritos fact. I've eaten 4, therefore I will have eaten more than 3. And by the rules of what we've established in our ability to do math, that's true. I don't need to do anything else. Whereas a posteriori is knowledge that relies on empirical evidence. The 4 burritos cost me $12 is a sentiment that you can't say definitively is true just through the reasoning of that statement, right? Um, I mean, I can somebody else can challenge me on the idea here as far as the cost of these burritos, but without empirical evidence, they can't say that this is true. They also can't say that it's false. So you do need to have empirical evidence to get the truth out of this statement. And so different schools of thought rely on whether math is capable of being more or less like derived from itself entirely. It kind of almost, now that I'm thinking about it, kind of sounds a bit like the chicken and the egg thing. What came first, the chicken or the egg? What came first? Our ability to have like did math exist already and we discovered it, or did we invent it? And so you have conventionalists believing that it is an a priori thing, believe that your axioms, your things that are believed to be self evidently true, should be chosen based on produced results and not for apparent coherence to human intuition, which is to say that you can't choose an axiom just because it feels good, right? We can't just decide that an axiom, this seems like it's right enough times, therefore I'm going to use it as self evidently true, just doesn't work. Empiricists would share this view and say that math cannot be known a priori at all, and the only way to discover mathematical facts is by doing empirical research. Um, Whereas alternatively, you have intuitionism that argues that mathematical objects arise from the constructive mental activity of humans, as opposed to from principles said to exist in objective reality, which is to say that mathematical knowledge is a priori. You can, left in a vacuum and to your own devices, figure out and come up with your own version of math that should effectively map over to whatever it is that we understand it as. Um, or consider something like fictionalism, where the idea of mathematics is actually entirely unneeded as far as numbers and points and other traditional math things are concerned. It's all just expressions of humanity, of something that we have ingrained in us.
So I think that there's probably a lot in life that's a priori, but it also, I think, might follow under the umbrella of fictionalism. I mean, all of our language, symbols, and whatnot have all been thought up, set and projected through time, but by the human will almost solely. We don't see animals drawing the symbol for two, for example, but you cannot deny having one thing and then another of that thing. I think this could also serve a lot towards the language used for intuition or instinct, just on like a general or maybe a
Well, and to that point, like, a mother goose has a idea of how many chicks she has. She may not know that she has 7, right? She doesn't know what 7 is, but she knows that if she has 5 of them or 6 of them, she doesn't have enough of them. And so she at least has the concept of the ability to differentiate that the amount that I have right now, this quantity, is not the right quantity. So her brain has to be able to it has to have been able to reconcile that one quantity is some different thing than some other thing.
I kind of think that like intuition is what I was going to speak on. Intuition is largely the mind, likely the subconscious mind, cataloging everything seen, heard, or acted on. It's still learned, but it's just indirectly learned. You're learning it as a consequence of being alive. It's just observing the environment around you. You see things coming and going. It's pattern recognition. It's what is that when you like peekaboo with a baby?
Object permanence.
Object permanence. Um
I'm pretty
now I
sure
lost
that's
my train of thought.
the what do you call it, that you don't have at first, that is a learned phenomena that comes along, that is a similar thing that you can do. You can do it with like your dog, right? It's
Yeah.
I'm sure people have seen it on the internet where you hold the blanket up over yourself and then you drop it and jump into another room and then your dog is like, where the hell did you go, right? If they didn't have any sort of semblance of like object permanence, I think if I'm not getting myself confused, then they wouldn't really have any sort of idea of like your presence.
Yeah, like yeah. Yeah, I think that's exactly how it works.
Right. It
But
wouldn't occur to them to question why you're gone.
yeah, but because of some combination of those things where it either I don't know how you learn that, but it develops. However, but so many other things in our world fall into that category where it wouldn't surprise me if up to a point it's just mathematics is instinctual just because you're seeing it enacted everywhere around you.
Right. Like everybody would eventually figure out that sort of difference between having one object and having two objects. You do. Whether you have the system to back any of it up, the words, the symbols, any of that doesn't really matter. You can still differentiate those things, and it's a thing that we have ingrained in the tool set that we get started with.
Yeah, it's just like a fact of the universe. Like as soon as the universe figured out that it wasn't zero, and if it could figure out it wasn't zero, it was not just one, but then two, and so on and so forth, like the legend of the Sephiroth. You know, just through consequence of existence existing, you have to have numbers in math. It's just terms that we're using for a concept.
Right. And so to break down like what the typical school of thought looks like, what most people likely subscribe to here, the Platonism, Formalism, and Conventionalism. We'll give each of these their definition, and then we'll talk deeper about each of them to kind of deconstruct that a bit. So Platonism is a form of realism that suggests that mathematical entities are abstract, have no spatio-temporal or causal properties, and are eternal and unchanging. Which is to say that, like the triangle is, was, and always will be a triangle. One and two is, always were, always will be, one and two. It's just the way they are. Formalism is a view that holds that statements of mathematics and logic can be considered to be statements about the consequences of the manipulation of strings alphanumeric sequences of symbols or equations using established manipulation rules. What this is basically talking about is that if you have x plus 3 equals 5, you can perform a series of manipulations on these strings, which is, you subtract 3 from your 5 from the one side. You subtract 3 from the one side, and you subtract 3 from the other side, and then you're informed that x equals 2, and that's the way it is. And then when you plug 2 back into that, you see the evidence of that being the case by seeing that 2 plus 3 equals 5. Um, and that's all that formalism is talking about, is that to to get to obtain truth in this way is to adhere to the fact that mathematical statements are the consequence of the manipulation of these strings using these very particular rules, which is saying you have a right way to do math. Then you have conventionalism, the attitude that fundamental principles of a certain kind are grounded on agreements in society rather on external reality. And so, what does this mean that this person actually believes? So, I would say that we could summarize this by saying that such a person would say that math is a tool made up of a series of non intuited rules of result production used to make sense of the various entities we see able to be created abstractly.
So just out here making number spirits.
Yeah, let it sink in. It's we have these entities. We could refer to them as angels. Maybe one is an angel as far as like the best way to describe it is concerned. um, and that the way you manipulate these angels is through a very particular set of rules that you do not use the intuition to create, but that you create these rules based off of the results that you get. Adding the angel of one to the angel of two must result in the angel of three because it is creates the correct balance as is given by the self-evident rules, right?
Yes. That that's kind of actually how you work with angels in like a very like basic sense. Um, I would like to take like a quick aside here. I think a lot, probably all three of these could hold their own in a Venn diagram depending on how you argue, each one, where things overlap or don't overlap. But in general, a lot of modern science, well, science throughout time has fallen under conventionalism, and because of that, the areas that do fall under conventionalism make it very hard to break out into new facts or schools of thought. One of the more famous ones could be like how long it took people on Earth to accept the fact that the planet centered the sun. That was, nobody believed it at the time. And then same thing with a round Earth rather than a flat Earth. That upset Catholics for a very long time. And then Alex, I don't know if you have this experience with PhDs, but in my world, most of them are like narcissists with inferiority complexes. So when you when you're playing around with a bunch of people who all think that they're the correct one, and then they form little clubs or societies where that group feels like they're the correct one, it's hard to get new science out. It does happen, but oftentimes there's a certain level of pushback.
Well, and the brain doesn't want to be wrong, right? It doesn't really like being wrong because it involves doing the extra work to reshape its like schemes, its schemas, and its archetypes, and all those other things that it has already been working out of, right? It doesn't want to have to do more work than it can because if you think about it as a machine, it's all extra caloric intake that it's trying to mitigate down to the very like even if the subconscious or any of the other underlying like things that you have in the brain that are more higher level than like the lizard part. The lizard part just cares about caloric intake and not wasting any of it. And so like if you extrapolate that to higher mechanisms, then that would then equate to the whole I don't want to change the way I'm understanding everything, because then that means that the things I've been doing may or may not be wrong. And then there's like the emotional extrapolation that comes from all that. And so it very much so makes sense that when you challenge somebody, the result of that is them being upset, because it does upset their worldview and their way that their brain works. But in a converse manner, for some of the work that like if you're thinking about like a real actual thing in PhD work, like if you go to tell them that like turns out Euler angles are not as accurate as they were supposed to be for when it comes to doing like quaternion integration or whatever, that's a big deal because it makes a whole bunch of shit not work right. And therefore, you should have a pretty decent bit of evidence to suggest that it's not that way before you go around claiming that it is, right? The heliocentrism in hindsight is stupid, or rather like that whole thing is dumb because it's very obvious to us now. But in sort of that vein of thought, if we look at all the things that we do know now and all of and the evidence that we have to suggest that it is the way that it is, if somebody comes out of the woodwork and says, hey, it turns out this thing is wrong, and they have only the first bits of evidence to suggest it, it's very easy to poo-poo that guy, because it would break a bunch of things that a lot of people have already accepted as the way that they are.
Yeah, it's I think just too much rigidity in science happens. And yeah, you're right. Like nobody likes being questioned, and nobody likes having more work for themselves. And I think I might just be jaded from a bunch of bad entomologists, but bug people are also just fucking weird. And I say that as a fucking bug person.
Maybe. And well, and I work in a bit of a different environment doing what I do, uh with the ARL, and we're not really in the business of doubling down on a preconceived notion we have. We're in the business of proving very thoroughly that what it is that we are suggesting is correct, because we're selling this product to somebody who's like paying us to be extremely correct. We have very rigorous requirements. We have a very safety critical mission, and ultimately, like, if so without saying too much, if something blows up where it's not supposed to blow up, that's a real bad thing. And so, like, having a high horse to be on about the rightness of one thing or another is not a good behavior to be doing. And so, if somebody comes out of the woodwork with a challenge to your thing, you better believe we're gonna check and double check that the efficacy of that challenge, because the last thing we need is something being wrong and
Yeah,
somebody
like
blowing up.
in my world, and this is way off topic from, but whatever. Like years ago when I was in college, I found out that at some point since I was in college, somebody did the research and figured out that praying mantises, cockroaches, and termites are all under like the same superfamily. So they're all sister taxa to one another. And that like freaked everybody out. Because it was I guess just so far from the norm from what everybody knew for or what they thought they knew for 30 or 40 years. So that kind of stuff happens all the time. And especially when you have some of those people still alive that said, hey, this is this thing and it's not related to anything else. And here's all the hard work I did. And I collected it and did DNA or did all the morphology, all the taxonomy. I published these papers, did all this work. Yeah, I could see, when somebody, pushes back against that, it's it's hard not to take it personal.
Yeah,
But
it's like,
if it's for the betterment of the
yeah, it's the defense of your
yeah, but if it's for
livelihood.
the betterment of the understanding of the natural or just the world we exist in, the reality we exist in, you know, I think it should still be. But that's my tangent on PhDs. Long story short, I think we're gonna go deeper.
Well, yeah, we're definitely going to take a little bit deeper look at each of these things, because I think each of these isms requires a bit more depth to understand like the full scope of what the air quotes typical orientation on math is. And so we'll start with Platonism. We'll just go in order. And so what we're arguing is that these mathematical entities are abstract. Nothing causes them, nor do they have space or time, and they are eternal and unchanging. Um, to reference a saying used to make people bug out, is my triangle is always going to be someone else's triangle. Is looking at it like how Platonism is, right? The word may change for it, the length of the sides could be different, but the triangle is, always has been, always will be. And the bug out phrase that I'm referencing is the idea that, like, my green is not your green. Well, the triangle is likely always your triangle too, at least according to Platonists. Um, if you draw a triangle for an alien, some completely other living entity that has mastered spaceflight, and then you point out, you go a little bit farther and you point out that each side, a squared plus b squared equals c squared, the Pythagorean theorem. The isness of that visual representation is likely to transcend language barriers and able to be recognized, because it is as close to something objective that we have as far as the understanding of our world, right? The the triangle, in the way that it forms in the world, it is, and other entities will have experienced that triangle. And the way that you convince them that you're smart is that you perform your manipulations on those sides to say that one side plus the other side squared equals the other side squared, and there's your illustration that you're not actually just a bumbling monkey, right?
Yes, about a bumbling monkey understanding the universal truths. But yeah, like to me, numbers are, or like this school of thought to me is just, this is the universal truth. It's the archetypal primordial isness of what it is.
Right. Like you mentioned already, they're just these ephemeral things. They are there, and in our explorations with mysticism, they're, like you already mentioned, they're the angels.
They don't have to be angels, but but they're angels.
Well, it's the catch-all. It's sort of it's sort of that word that is the way that it is. And so that comes next to formalism, which is the whole nonsense about the string manipulation and rules and whatever, is just basically saying math is a game. It's looked at as a game. It's puzzles to be solved in cases. Again, we can go back to the whole x minus x plus 3 equals 5. The game here is, what is x? Oh no. Well, the way that you get x is you subtract the 3 from the one side and you track the so 3 from the other side. You balance the things that you do. You achieve that balance, and when you've achieved that balance by performing the opposite onto it, the removal of the 3 from one side and the removal of the 3 from the other side, you are enlightened and illuminated to the truth that x is 2 by the evidence suggested right in front of you from the operations you performed. And we do these this symbol manipulation, and we follow these rigorous rules, but they don't really like mean anything, and they never will, right? They're just the way that they are. So when you look at the Pythagorean theorem again, it's pretty much like it's nothing until you put it next to the triangle, and then you ascribe each of those sides the a, b, and c, and then you look at that triangle in the shape of your sandwich, and then you can see that, oh, these different sides here give me these values, because I know that this length of this side of my sandwich is this and this side of my sandwich is that. And then I have the other sort of side, and then you can basically calculate your surface area of your sandwich to know how much sandwich you eat, right? If you cared, you may not care. Um, but like, not to reinforce the uselessness of all the algebra and calculus that you may or may not have done in the K through 12 or college or whatever, but it doesn't do anything, or like, without anything to make it matter.
Yeah. So in my notes, I've got Terrence Howard written down. You know Terrence Howard. You know who he is. To the uninitiated, Mr. Howard is a man who, for lack of a better word, thinks, and I think he probably thinks too much. Uh, so he states that math is a universal language. I think we can agree on that. But how we have learned math is largely manipulated and incorrect on purpose. He pushes against the accepted mathematical axioms and argues that the rules are arbitrary and do not accurately reflect how the universe operates. One of the core tenets of teleology is that math is flawed, like I just said. So when you multiply an action by an action, this is his words. When you multiply an action by an action, it should result in an increase or a reaction, not an identity. I don't know what that means. That's his words. For example,
Uh-huh.
1 times 1, he says, does not equal 1. 1 times 1, he claims, equals 2. I guess. In his wisdom, he ignores irrational numbers. He proves our current understanding of math doesn't work. And he uses that with the example of the square root of 2. And Alex, I did the calculations on this. The square root of 2 is 1.41 repeating, which, of course, if you did the inverse of a square root, it would be more than 2, I guess.
Well, so that's sort of the thing, right? Is the deal with the square root of 2 being 1.41 111111111 or whatever. Like it says repeating, it may just be that it doesn't repeat, but it continues to, it continues and continues and continues and goes on for seemingly forever, for a possibly uncountable amount of spaces, right? But as you continue to do those spaces, you get more and more resolution, if that makes sense, which get you closer and closer to actually be, when you do the inverse, actually being 2. That's sort of the part that he's missing, is that if, say, for example, you had the time to actually have all of the places for to represent the square root of 2 as the actual continuous value, then when you did the inverse, you would get 2 because you would have all of the values that you need.
Didn't he get kicked out of, because he was in the first 2 Iron Man movies? I want to say, I don't know if it was kicked out, but I think he may have left over a dispute and maybe wanting more money than Robert Downey Jr. I could be wrong. I'm not going to Google it. I don't know any more than that.
Going back to the multiplication thing, just to make sure that that our listeners understand the matrix, or the multiplication thing. Like multiplying 1 times 1 and having it not equal 1 and equal 2 doesn't make any sense, because it's a misunderstanding of the operation that's being performed, right? Like he's saying multiplying an action by an action, it should result in an increase or a reaction, not an identity. There's some truth in that if you think about it from a perspective of actually like mapping an action, and there's math for this. It's called linear algebra, and it's called vectors, and you can effectively describe an action, such as the path of motion, by an equation, or you can, such as simply x equals 2, right? If you are traveling at 2 miles per hour forever, x equals 2, and you can map that on some sort of like a graph, basically, and then you can take derivatives and integrations to see things like acceleration and momentum and shit like that, right? But you can also map your your movement as a vector in three-dimensional space by using a matrix and defining a place in each of that matrix, or each of those a place in your matrix as a dimension, right? So if I'm moving forward in three-dimensional space and I'm not moving downward, right? Let's say I'm just walking on a flat surface.
Yeah.
Then I am moving by some amount in the x direction, some amount in the y direction, and by no amount in the z direction. And you could describe my movement as that action. And then when you multiply it by another action, say I choose to go into another direction, then to do the matrix multiplication, I don't remember exactly how you do this linear math, but to multiply those two matrices together, the actions, there are specific rules that involve taking the x and multiplying it by like the y in the other thing, and like taking the y and multiplying by the x in the other thing, and then like multiplying the x and the z, so you can end up getting a new matrix that describes you going in a different direction. But simple multiplication of two, like angels or numbers or whatever it is describing an action itself. The action is that it's describing is you have a bowl of olives, for an example. I would like to perform a removal on that bowl of olives 1 times, right? And I'm doing it by an amount of 1. And that's what the multiplication description is saying. Remove 1 olives 1 at a time. And so when I remove 1 olives 1 at a time, I get 1 olives. If I remove 2 olives 1 at a time, I get 2 olives. If I remove 2 olives 3 at a time, I would remove 3 olives, and then I would remove another 3 olives, and I would have 6 olives. 2 times 3 equals 6. That's what's actually happening there. And so, you know, there is truth in his thing that he says about the multiplying action by an action. Yes, if you are doing something like describing motion in space and then doing linear algebra, but not if you're talking about the angel that represents 2 multiplied by the angel that represents 3.
Yeah.
You receive the angel that is 6.
Yeah. So for my gym bros out there, if you're doing like, 3 sets of 15, that's what we're talking about. 3 times, 3 times 15 is whatever that number is. I'm not doing the math right now. But like,
It's 45.
3 sets of 15 squats, doable.
You got to do 45 squats.
45 squats.
You're supposed to rest. You should rest in between.
Yeah, rest in between each one. But yeah, if that helps you conceptualize it, it helped me. I'm not that much of a meathead, but that, 3 by 5 wall squats
Yes.
right now.
And so that was a bit of a tangent of it. And this is just me picking apart Terrence. And like, it's not like it's a wrong way of looking at any of this. It's just doesn't it's taking and misunderstanding a thing and then trying to sort of market it as this other sort of thing. It feels like more of a grift than anything else. It's not like there's anything profound going on here. It's just a lot of like it's misunderstanding sort of creating this sort of something that seems more profound than it is by taking advantage of the lack of knowledge one might have over such a thing.
Well, he's on this whole, the governments are doing this on behalf of some aliens, I think. It's can we
I guess. I don't know why that matters.
I don't know. I it's time to move on.
Conventionalism, as we mentioned before, is it revolves around the idea that axioms should be chosen based on the results they produce, not based on how they might feel as far as their truth. This is best understood, not to say that you're going to understand it or that I really understand it, through Euclidean versus non-Euclidean geometries. Euclidean geometry is kind of what you see when you look at the walls in your house and how they hold up the roof and that they are shaped in the way that they are and how all of it kind of works. That's Euclidean. When you look at that, I don't know if it's MC Escher who does that and
Yes.
has the weird painting with
Yes.
the stairs. Okay. That's like that's like one of your non-Euclidean geometry representations, like weird ways that like space can be represented and warped in that manner. But back in the day, Euclid's axioms that he created as part of his geometry seemed so intuitively obvious that theorems proved from them were deemed absolutely true, and that no other geometries were possible. Poincare, and I don't know how to pronounce his name really, is he's French or something, and Einstein, however, have made the absoluteness of the Euclidean axiom have made that the axioms of Euclid are not strong enough to be considered universally true and require this like kind of scoping, right? The scoping being that like in the macro world that I refer to the things as the macro world, Euclidean geometries make sense, right? But that in more advanced physics principles and in possibly like, from the micro perspective or at the quantum level, um, that may not be the case. And the very famous reason that has come up is that Einstein's theory of relativity suggests that physical space is not actually Euclidean. Like the space that we live in isn't actually Euclidean, but that you can use Euclidean space as a good enough for short and human perceptible, distances, with the relative strength of gravity changing how the space behaves. And so that, like, like this is to suggest that we perceive things Euclidean, and so our intuition was to suggest that that is the truth of how the world must be, but that the theory of relativity and all the other things that Einstein proposed would suggest that our perceptions are wrong, our intuition was wrong, and that space may in fact behave some other way that is completely imperceptible and didn't necessarily make as much sense, right? Um, so in summary, just because something seems to be always true doesn't mean it is. And we should probably be very picky about how we decide when something is considered
Yeah,
axiomatic.
and I think this is very hard, especially in like the esoteric realm, because you get into a lot of pseudoscience, and when you get into pseudoscience, it just occurred to me that pseudoscience has a lot of feelings because it at least in the realm of the occult or paranormal, it is things that you experience on an experiential level in a way that you maybe cannot quantify with concrete data points. Now, the flip side of that is to understand that science does change throughout time. And, you know, because of that change, people shouldn't get caught up too much on the concreteness of things. That change can happen. And if you're paying attention to the world around you, things are changing constantly. This, you know, I don't know if the general public doesn't understand how much of the realm of science says this is the current fact based on the data points we have at this moment. So facts are based on the current knowledge set of all the input going into it. And then even scientists forget that science itself is subject to change. This is like what we were talking about earlier. They could just be obstinate to the change. And I'm not saying that science can't be trusted. It definitely can be and should be, but it's only as good as the information that we currently have. But you have to approach it from actually, we have to approach it from actual describable, repeatable information points, data points. So it can be kind of like Scrabble. You can only make the words that you have with the letters that you have at that moment. Can you change the words or make different ones later? Yeah, absolutely, you can. And sometimes you're going to piss some people off when you do that, but hey, it's just a game. But yeah, things do change over time.
It it reminds me of a time I remember we got back to playing Words with Friends, and I think I baited you into a triple word where I played the word Jeeps, and it came out to be like 100
Yes,
something plus
yeah.
points, and you just
We
quit.
have not played.
It
Like
was
we played pretty regularly. Like every
no.
6 months we get on a kick and then play it for a month. And then that was like 3 or 4 years ago. And I said, fuck that, because that was too good.
Nope,
Never again.
never
I still
again.
don't play Scrabble.
That was bullshit.
Yeah,
Scrabble's
it is.
fun though. But I mean, like, I think you're absolutely right. You kind of almost can use that as a way to talk about our discovery of the universe. Is just like literally, we started with a bunch of words on our little plate thing here, and we were trying our best to take and make the best word that we can with what our plate was. We reach into that bag and see what we get next, and then we have to try and figure out what the next word is. And like looking back over time, you can probably find better words, and those are what get you the most points. And you can kind of think of it. You can put all this together and kind of create this little story of of human discovery being this game of Scrabble that we continue to, lament about whether we could have done a better played a better word. And when we do find the best word, that's like the ultimate goal. And it's not to be pissy about it or any one thing when you do find out that turns out there was a better word. just okay, remember that. Well, there was a better word at that time, and then we remember that, and we keep playing the game, and it's this game that goes on forever. You constantly it's an infinite board with infinite letters, and you keep playing
I
it, and you
I
keep
think we
finding
just
more words.
unlocked some hot new tech for reality. People are, they're talking about simulation theory and how are we just a video game. People who do their DMT trips, they see, oh, it's a video game. They can see the grid. We're in the Matrix. No, we're just playing a game of goddamn Scrabble. God's just playing a game of Scrabble with the angels.
It's all been
Christ,
Scrabble.
isn't that bleak? No.
No,
Hey, we're playing it with friends, right?
no, I like Scrabble. Yeah, exactly. You can't play Scrabble by yourself.
I know someone's gonna be listening to this while tripping balls,
There
and they're
wouldn't be
gonna
a
hear that and be
point.
like, yeah.
Well, I mean, I think that it, we can do like a bit of our own. This is sort of our own sort of philosophical gematria in a sense, but like, there's no point in playing Scrabble by yourself. And it comes back to, I think, the idea there that like, you, if you think about like what's the point of experiencing? The point of experiencing is to experience, because if you weren't experiencing, then what's the point of everything else? And so like, you kind of you can kind of take that into consideration and think, what's the point of playing if you're not playing with someone else? And so you are playing with someone else. You're
Yeah.
playing with the universe.
And think of how exciting that is to like riff off, the universe and create these amazing words that you didn't know that you had or that you had the letters for.
That's it, and that's just it. You know what? I've enlightened myself just now. It's come to me. You are playing a game of Scrabble with the universe, and as the words that the universe gives you, that like you see those words that the universe gives you, and you make your own words. We make our own symbols, we make our own axioms, we come up with our own information, we try our best to play the game, and the universe seems to be extremely good at it, almost uncannily so, and we continue to try and play our best game, and we probably will always lose. But the universe is a very humble winner and lets us continue to play forever. And
That's
that's
sick.
and that's
I
what it
love that.
is. That's another, there's your
I love
simulation
that so much,
theory.
but that's so much cozier. That's like I'm sitting on the porch with like a grandfather playing Scrabble. I'm sitting. It's like the disgusting old like kitchen table that everybody has. It's worn, not disgusting, but like worn from everybody. I love it. That's beautiful. What? Yeah.
Well loved.
Hell yeah. Can we?
And I think with that, then we'll take a break, not a break necessarily, but we'll break here because there's more stuff that I want to talk about. We'll end with this very nice and heartwarming sort of rendition of what life might be, before we go into what I think is sort of the more esoteric parts of looking at math. And I think this was a lot more structured, and I want to take the more esoteric and weird approaches to math and be a little bit more freeform with it, for the second part.
I'm
So,
excited.
like usual, look forward to that.
Yeah, I'm excited. This was a good conversation. So I'm really excited to jump back into this topic.
Absolutely. So, I will, knowing this, I think this being 2 episodes, I'm going to try and see if I can't get myself a couple more notes for this and see if I can't like pad out a bit of the esoteric side of the mathematical philosophies here, to make sure that we've got a good 2 chunky parts for everybody.
Yeah, yeah. Like I think this was fun.
Oh, for sure. But like usual, we will be seeing you next time. Please reach out over the net here. Touch us on the internet there, at our various places of contact. Please, like, comment, subscribe, and tell us what you do like. Tell us what you'd like us to talk about, and we'll see you next time.
All right. See you, everybody.
Nice, good.